Well, here's a tired looking Cybernet Beta 3000 in from an end user. It's even got a dent where it's been shoved in a skip. But were very expensive sets. Certainly the Radiomobile one was $119.99. So it's been very damp. It's probably been in somebody's shed or the car boot for 5 years. And he's got no display and no sound out of the internal speaker, though he's got sounds through the extension speaker socket. So we may as well look inside immediately, because there's no point trying to fill in a form with a set this crusty. Worry about the speaker later. Make sure there's nothing silly inside. Not sure why they've been fiddled with. I think we'd better take the bottom off this. Well, I can't see anything strange there. So really the channel selector switch shouldn't have a snag. Got a dimmer. Make sure that plugs out and in again in case it's a dirty connection, because you've only got the rotary channel selector switch, which is conventional on these, and the display is directly driven, so it's not like there's any electronics. It's just the BCD switch. I can't see any distressed capacitors. I can't even see any broken cores, so it just looks a tired genuine set. So we'll power it up. I normally have a little stub on here, but Mr. Chippy's just finishing off a set from last week, and there's my little stub, and he's got the full power lead bash on the back there. Right. Oh, I've got to unplug the test instrument from behind, so I'm having to use that deviation meter. I've bought an accessory deviation meter. It's a Heathkit one, so we'll go through that together. From America. I don't know whether it works. It doesn't matter whether it's supposed to work or not. There won't be anything in there that can't be fixed, and that's the wonderful stuff about Heathkit things, because we can't take this test set off here to do any service work, because it would be down too long. So we just have to put an accessory one like we have with the cyanide meter. Eventually there'll be no functions working on it, will there? Well, that'll be the retirement point. Right, so I need the standard Cybernet mic. I'll start with a sheet, but we don't know yet whether it'll be going back non-working. I've had a reminder from RS Components that I owe them £4.40. You know, does it really matter? How many thousands a year do we spend with them, and they want £4.40? Just add it on to next month. It really doesn't matter. Obviously it does to them. One of my local churches hasn't paid me since Christmas. So, there you go. What do? So I'm not going to play. Oh, I'm not playing the organ. They will play. Probably at Christmas. I think it's the 28th today. Right, here goes. Don't like it. I'm going to leave the bottom off, but it can affect some of the readings. So on off. We've got a dim RX light. And it has got a display. Of sorts. So dimmer. So it is in the bright position. That's duller than it should be. Let's put it into transmit. Yeah, the whole front panel's dim. I just wonder whether it's not getting the right voltage. But this, being haywire, I really don't know. That looks like channel 20. Yeah, that is channel 20. Huh. See a bit of poking and prodding and it now says 20. So there's a dry joint somewhere. But I still think that's dimmer than it should be. I may be wrong. Right, well, we'll try and find channel 40 on it. I'll worry about that later. So this could be dirty channel switch. I'm still intrigued as to what's under that insulating tape. Why? So, start with the VCO. We need to have crocodile clip lead. So, one donated by Alan. Change glasses. Should be 4 volts. It's 3.87. That isn't a problem at all. And TX which we've lost all power. How can my crocodile lead clip come off? It hasn't. How can the radio stop working? It can. .38. Start with receive. It hardly needs adjusting. So I don't think you'd have any channels dropping out. It's so. I'm not going to adjust that. It's so close. But the transmit one. back to receive, transmit, check channel 1, whichever way that is, that must be that way. Between 1.8 and 2.3 it's supposed to be, that's fine for receive, and that's fine for transmit. So that's that done. So let's look at the transmit power for channel 20. So let's put picture in picture on. It's 4.4 watts. That's not good. Sounds like it's had the golden wally. Channel 40, 4.1 watts. Channel 1, 4.8 watts. Deviation, not that we're going to get an accurate reading off this machine. Wallow, 1 2 1 2 1 2. Wallow. I'm getting 3.2 at the moment. Might be right, it might not be. Oh, good grief! I filled this in the wrong place. Back to channel 20. And let's look at the current consumption. It's 1.187, which isn't bad. And on low power, oh, it's at the back on these. How daft. It is 25 milliwatts. Use the preset dirty. The meter, let's go back to normal power. The meter reads 4. I'll worry about receive in a bit. We'll just check the PA function. Testing 1 2. Testing 1 2. I don't even know if the set's still on. It's gone down. It's dark. Nothing's plugged in again. I'm not sure why these are falling off. I'll take this meter away. We're done with it. The meter's a snag. I'm sure it is. Frequency, when we get the power back on, was 080. Testing. So which one is it? Testing 1 2. Testing 1 2. Yeah, that works. And back. Good. Let's go through transmitter. So I've still got to make sure this is tuned up, but I want to do it quickly because the PA can't sustain above 4 watts indefinitely. It's at 4 watts it's something like 5% duty cycle, so 5% transmit, something like 15% receive, 80% standby. So go back to the 30 watt scale. So I've got that as peak. That's peak. That's peak. Now to these. So we've got to peak these on a temporary basis. The green one was at max. This is a bit tight for that tool. Possibly the blue one. So our peak, I've just got to recheck 5.1, which is one of the better examples. So now it's the blue one anti-clockwise for 4.4 watts. The set suddenly stopped transmitting. And then the green one anti-clockwise for, they say 3.8 watts, but we said it's 4 watts being the legal limit. And now it should be balanced across the 40 channels and not being thrashed. So, staying on channel 20, if I can get a display on the thing. Yeah, we're on channel 20. Channel 40. Is 4 watts. And channel 1 is 4 watts. So that's absolutely spot on balance. So the current consumption, mind you, this is a bit disingenuous because the display's not working right. I suspect it's this. Oh, we've got a dry joint. I'll just look for a dry joint. Right, we'll see whether that's done anything. Dry joint on that connector. I've gone around them all. Then I've gone around this with isopropyl alcohol. This has been taken off and put back on for whatever reason in the past. So I've also cleaned up that. At the moment, we've got a channel selector that is showing the numbers. How handy. So back to that current consumption, which when I did it before, of course, it was going to be under because we weren't drawing the current, were we? About 200 milliamps. So we'll now look again. We've got a Duff wiring at the mic socket. .154. So by tuning it properly, we've actually got the power right. Add 200 milliamps to that for the display not being on. So that's good news. So the frequency which we were about to look at, if I can get it to go into transmit. 79080, yeah. I don't think it's so much the wiring, it's probably corrosion on these pins. So we'll just go over that with a fiberglass brush. In the hope play. Let's take that off. Right, 27791. Oh, we're going to do the frequency, weren't we? That's what we were in the middle of doing when we couldn't go into transmit. Well, I'll kind of hold the set so it goes into transmit. If we can find the trimmer capacitor. $27,79126. Right, see where we are with the signal generator. So I want 2779125 on the signal generator. Just like that. Silent meter on. Actually, it sounds absolutely great on receive. So for 12 dB, it's 0.31. Let's put the No, we'll do it this way first. 0.31. For 20 dB, it's 0.27. For 20 dB, it's 0.86. Very good. Make sure I'm in the right scale. Yep. Squelch tight. So I've got the squelch on full. I want it to open at 100 microvolts. 1, 3, 10, 30, 100. It does. And let's see how sensitive it is. Turn this down, put the signal generator to standby. Set threshold. Signal generator back on. 0.45. That's excellent. And the S meter, it's probably reading right. You know, what can you say when it just says 1, 2, 3, 4? Oops, I put it in that one. Right, let's go through the receiver then. So we'll start by putting the oscilloscope on S9 on the signal generator, 100 microvolts. Let's see whether we've got maximum recovered audio from the detector. The answer is not quite, so there's a very small improvement there. Let's go over to the cyanide meter. Squelch off. Little improvement there. No improvement there. No improvement there. Put a bigger signal on for the IFs. No change. Slight change. Then the hidden one under the wiring harness. Excellent. That's it. Just that one that was slightly out really. And the yellow IF very slightly. See, we've got an improvement in what the cyanide meter says, or whether I've made it worse. So I've just changed scales. So we're reading off the same scale, 0.24. For 10 dB, 0.21. For 20 dB, 0.49. See if the squelch is still the same. So squelch to full on the radio, put the attenuator back up on the screen. So 3, 10, 30, 100 is fine. While we're at 100 microvolts, let's see if the S meter is how I want it. So I want it to be just doing that 4th bar. So it is just doing the first. So turn it down, yeah. And now we'll turn the squelch down. Put the signal generator to standby at 0.3. Set squelch to threshold. Signal generator back on. Not 0.8. It has changed. Meter is set. No meter lamp. They're all right. Don't know about that yet. So we'll just see if we can set the transmit power on. If we can persuade it to go into transmit. Yeah, I'm just starting to think, is it my plug that's playing up and not the radio at all? So I can't have used this more than 300 times, so I'd expect it not to be malfunctioning. No, that's solid enough. I tend to load these teeny weeny screws onto a precision screwdriver, then hold it with my finger like that, and then, having lined up the connector, I find it really easy to put in. This is probably part of my organ building skill. Right, well, I don't know what we're going to do there. There's one or two things to address, but I think the main things we have. I'm going to take a break. I've got some other things to do. Okay, so I cured the mic problem by putting a different mic on it, so it works every time on this mic. Let's just put that on there. Key up, key up, key up, key up. Fine. What deviation have we got now? Wallow. None. Wallow. 3.5 now. Well, I'm just tempted to set it on this meter, and then I'll double check it on the test set behind me. So the other thing that's duff is the loudspeaker. He said it didn't work on the internal speaker. It could easily have been something to do with the socket, but it isn't. It's the speaker, which is open circuit. So I just tested that. I've put my reading glasses down. I'll probably trundle on them. I can't believe how much 3-inch speakers are. Gone are the days when they were £1.79 out of Tandy's. Nasty dead insect in that. So we've got the wiring, and this is going to have to be soldered on, which I don't like. To be honest, I don't use internal speakers very much. We do that. The one in the car we use the internal speaker because it's part of the demonstration. But on all the other vehicles and that, we do use external speakers. And I certainly recommend that most people do. I'll tell you what, we'll do the deviation first. Fit about the speaker. So I want the vertical one to its centre position. That's now in its centre position. So I'll do this initially. I'm going to just do the while. I can't really use the oscillator because I'm leaning to the bench behind me and it's out of my reach doing it that way. So we'll do it a bit more basic way. Wow, that's now maxing at 2.5. Right, I'll unplug the test set. I'll switch picture in picture off. And I'll now plug this input lead into the test set behind me, which has been on more than half an hour, and see what the deviation is. Well, it's still 3, so I've still not got the accuracy on mine. Found the glasses. So if it was, I think it was 4.2 in fact. Anyway, we've now got it at 2.2 with a peak of 2.5. The sockets are fine. Speaker, replace speaker. I know what else we haven't done. We haven't cleaned the low power. So whilst the soldering iron warms up, I'll go and recover my input lead from the test bench behind me. Right, I'll just select low power on the radio, which is on the back, isn't it? Put picture in picture back on. Select that, go to the 3-watt scale, key up. We actually have, do you remember it was 20 milliwatts before? Well, it's not now, it's 110 milliwatts. Yeah, I can see it's a bit dirty. It's one of those things with these. There we go, 400 milliwatt. Key it up again, 400 milliwatts. Good. So, I'm going to have to solder these to here. I really don't like doing this. It's been all these years. But instead of cutting them off, I'm going to just do that and just put a dab of solder. So it would be possible, if a correct speaker ever turned up, it would be possible to clean the solder out and do it how it should be done. And there we are on the internal speaker. Good, that's it. We're done. So Mr. Chip is wanting to do a test, so we'll get a couple of case screws in. Worry about that later. I know there was one missing. And plug in the roof aerial, which is the Antron 99 type, maybe a Solarcon 99 or whatever, but it's something 99. A quick flick around the channels. 19 Roger. That knob's in the wrong position. That knob's in the wrong position. That knob's in the wrong position. That one's right. "19 a Roger." No, okay. We're doing on the air test. Hope you found that interesting. Dry joint was the display. It's tuned up a treat. Thanks for watching.